What if the universe we observe, with its billions of galaxies and vast cosmic structures, is merely a small fragment of a far greater, unimaginable reality? What if our very existence, our planet, and our entire cosmic neighborhood are just one among countless others, each unfolding across different realms, governed by its own unique laws and histories? Today, we dive deep into one of the most profound and mind-bending concepts in modern physics, the multiverse. The modern idea of the multiverse truly began to take shape in the 1980s as physicists grappled with understanding the explosive early expansion of the universe, a phenomenon known as cosmic inflation. Proposed by visionary physicist Alan Guth, the theory suggested that space-time might expand unevenly, creating distinct regions. Some regions would eventually slow down their expansion, while others would continue inflating rapidly and indefinitely. Each region where inflation eventually ceases becomes a distinct universe, a self-contained bubble with its own unique destiny and physical properties. If this process of inflation is indeed eternal, then the creation of universes is not a singular, one-time event, but an ongoing, never-ending process. New pockets of space-time continuously appear, each separating from others like bubbles forming in an ever-expanding foam. Our universe is simply one such bubble, a tiny speck in an infinite cosmic ocean. Far beyond anything we could ever hope to observe, countless other bubble universes might exist, each isolated within an immeasurable and incomprehensible cosmic expanse. The motivation to seriously consider the existence of parallel universes stems from some of the most profound and unresolved puzzles within our own cosmos. For instance, why do the fundamental constants of nature, such as the strength of gravity or the mass of an electron, possess precisely the values needed for stars to ignite, complex chemistry to occur, and life to emerge? Why does dark energy have a value that allows galaxies to form, rather than tearing the universe apart too quickly? A multiverse offers a compelling landscape where each universe could possess different fundamental constants. In this scenario, our universe is simply one of the rare and fortunate places where conditions are perfectly balanced to allow complexity and life to flourish. In the realm of quantum mechanics, another fascinating version of the multiverse emerges, known as the many-worlds interpretation. According to this theory, every time an event has multiple possible outcomes, all outcomes actually occur, but in separate, diverging branches of reality. This means that one version of you might make a particular decision, while another version of you, in a parallel universe, takes a completely different path. Entire timelines unfold differently, producing an ever-branching, intricate web of universes. These quantum universes aren't separated by vast distances in space, but rather by their distinct quantum states and histories. Consider the profound impact if the values of physical constants were even slightly different. An entire universe would be fundamentally reshaped. For example, if gravity were just a little stronger, stars might burn out far too quickly, preventing the long-term stability needed for planets and life. Slight changes in nuclear forces could prevent the formation of heavy elements, which are essential building blocks for planets and biological systems. Consequently, most universes within a multiverse might be dark, sterile, and utterly structureless. Only a tiny subset would possess the precise balance of conditions required to support the formation of stars, planets, and potentially life. The remarkable fact that our universe fits into this rare and specific category is one of the strongest motivations behind the various multiverse ideas. String theory, a leading candidate for a theory of everything, adds even more profound depth to the multiverse concept. It proposes that reality may not be limited to our familiar 3 spatial dimensions and 1 time dimension, but could instead have 10 or even 11 dimensions. The way these extra dimensions twist, fold, and compactify into tiny, unseen spaces fundamentally determines the laws of physics within a given region. Different configurations of these compactified dimensions would produce entirely different universes, each with its own unique set of physical laws and constants. The number of possible configurations is truly staggering, far exceeding any physical quantity we can currently measure or even comprehend. Some estimates suggest a number greater than 1 followed by 500 zeros, hinting at an almost infinite variety of potential universes. To bring some order to these diverse ideas, physicist Max Tegmark created a comprehensive 4-level classification of the multiverse. Level 1 consists of distant regions of space within our own universe that are simply beyond our observable horizon, regions we will never be able to reach or see. Level 2 includes universes with entirely different physical laws and constants, such as those arising from eternal inflation. Level 3 corresponds to the quantum branching described by the many worlds interpretation, where every quantum outcome creates a new reality. Finally, Level 4 contains universes based on entirely different mathematical structures, representing the most abstract and diverse possibilities. This framework attempts to describe all conceivable layers of possibility and existence within the multiverse hypothesis. The multiverse, in all its forms, raises profound and often unsettling philosophical questions that challenge our fundamental understanding of existence. If infinite versions of us exist across countless realities, what does that truly mean for our personal identity and individuality? If every possible decision we could make is realized somewhere, in some universe, what then becomes of our concept of free will and personal responsibility? And if infinite universes truly exist, then everything that can possibly happen does happen, somewhere. This includes alternate histories of Earth, alternative evolutions of life, and realities completely unlike anything we can even begin to imagine, forcing us to reconsider our place in the cosmos. Despite its compelling nature, the greatest challenge for the multiverse concept lies in finding concrete evidence. Universes within separate bubbles, or those existing in different quantum branches, may never interact with each other, making direct detection or observation nearly impossible with current technology. Still, dedicated researchers have actively searched for subtle patterns in the cosmic microwave background radiation, which might reveal faint signs of collisions with other universes in the distant past. While some intriguing anomalies have appeared in the data, none have yet provided definitive proof. Yet, the field of physics advances rapidly, and new tools and observational techniques may someday reveal undeniable traces of these hidden realms, transforming speculation into scientific fact. Even without direct, irrefutable evidence, the multiverse remains a remarkably scientifically useful concept. It offers a powerful framework that helps explain why our universe appears so incredibly finely tuned for life, providing a context where cosmological puzzles make logical sense. Furthermore, it motivates entirely new approaches to unifying quantum mechanics, gravity, and the fundamental structure of space-time, pushing the boundaries of theoretical physics. Whether the multiverse is a real, physical entity or a powerful theoretical construct, it undeniably enriches our understanding of how physical laws might emerge from even deeper, more fundamental frameworks, driving scientific inquiry forward. Thinking about the multiverse also profoundly affects how we perceive ourselves and our place in the grand scheme of existence. It challenges our ingrained sense of uniqueness, while simultaneously highlighting the incredible improbability and preciousness of our own existence within this particular universe. Even if there are countless realities unfolding, our world and our individual lives within it still hold immense meaning and significance. Reflection on the multiverse expands our perspective, reminding us that the cosmos is far deeper, stranger, and infinitely more beautiful than our everyday experience might suggest, inviting us to embrace a broader understanding of reality. Real or hypothetical, the multiverse stands as one of the boldest and most imaginative ideas ever proposed in human history. It fundamentally reshapes how we view the cosmos and our intricate place within its boundless possibilities. And ultimately, it invites us all to pursue the biggest and most exciting question of all: what else is truly out there, beyond our current understanding? If you enjoy exploring profound mysteries like this, please like this video, share it with others, and subscribe for more journeys into the wonders and enigmas of the universe.